All right, today we're going to be looking at radicals. Radical is a generously named thing in math. It sounds a lot cooler than it is. But basically a radical is just a general term for a root, like a square root or a cube root. So it's just this symbol right here. But again, it could have like a little 3 or a 5 if you're talking about the fifth root, for example. A mixed radical is kind of like a mixed fraction. A mixed fraction, is something like 2 1/3. So a mixed radical, similarly, is a coefficient and a radical. So something like 2√3 is a mixed radical. Like radicals, kind of like terms, you have to have the same number under the radical. Just a fun little fact is that number under a radical is called a radicand. But you can only add or subtract like terms that have the same radical or radicand also. So if you have 5√3s and you're subtracting 2√3s, that's 3√3s. But if under here it was like 7 or something, then we couldn't do anything. So the first skill is we are going to practice writing mixed radicals. So when you're doing these questions, you should really be trying to find the largest perfect square that goes into a number. So 20, for example, only has, other than 1, only one perfect square that goes into it, which is 4. So I'm going to take this 20 and I'm going to split it into 4 times 5. The reason why we're looking for perfect squares is because the square root of 4 is 2. So I've successfully written this as a mixed radical. It's 2√5. You should always look to see if there's like another perfect square that goes into this radicand. Because if there is another perfect square other than 1, then your job is not done. Okay, so here 45. I know that 9 goes into 45. So again, I'm going to split this 45 into 9 and 5. Square root of 9 is 3, and I can multiply these as I normally would. Same idea here. Square root of 9 is 3. So root 63 is 3√7. Now to simplify these, once again, I said that you can only add or subtract like radicals. So this √3 and this √3, those are like radicals. And this √5 and this √5 are also like radicals, which means that there are 3 √5s, and that was 1 minus 4, so -3 √3s. Sometimes it's a little bit harder to see. So as it stands right now, it doesn't look like there are any like radicals. We've got a √8, a √2, and a √32. But if we simplify, we'll see what happens. So again, 8 is broken into 4 and 2. 2 is good. 32 is 16 and 2. And as soon as we simplify, we can see, oh wait, actually everything is a mixed radical with √2. So again, we do 4 plus 3 minus 4 is 3 √2s. So always try to simplify first. Here, again, it doesn't look like anything is going to simplify, but as soon as we do some work, we can see that we have some √2s, some √3s, and we can gather them appropriately. Please don't try to oversimplify. So here, these are not like radicals. So these cannot simplify further. So don't add those. Okay. Here, √5 times √3 is √15. So that is legitimate. And you were actually doing that unknowingly up here, just in reverse. So here, √9 times √7 was √63. So you can definitely split them up like that. Here you can also distribute. So I can do √3 times 1 plus √3 times √2. But again, this does not simplify any further. It's not root 9 or anything. Here, again, I'm going to just distribute like I normally would. And I'm noticing here that it's not fully simplified because root 18 has a perfect square that goes into it. So I'm going to make sure that I split that up and rewrite it as a mixed radical. So always make sure that there isn't a perfect square that goes into the number. And here, squaring this is going to square both the coefficient and the radical. And squaring a radical will cancel it out if it's a square root, and we get 20. Okay, thanks for watching.